All right. Hello and welcome everyone. I hope you can hear me. If not, please say so in the chat, or you likely don't hear this either. So welcome to the webinar on ICS SCADA red teaming. My name is Jos Wetzels, and I'm here with my colleague Razvan, who will be facilitating. I'm a principal consultant and security researcher with Secura, and I'm primarily focused on embedded system security, ICS, automotive, IoT, medical devices. And previously, I worked as a security researcher at the University of Twente, focused on critical infrastructure protection. So a little bit about Secura as a company. We have a variety of service offerings across different kind of aspects of security, people, process, and technology. And those relevant to ICS SCADA are our ICS SCADA security training, our IEC 62443 assurance and certification services, and of course our red teaming services that I will be talking about today. So let's move on to that. I'm going to start today with a little bit of an introduction, then discuss the red teaming process in general, discuss the ICS SCADA nuances, and finish off with a conclusion. So when talking about ICS SCADA red teaming, we have to start talking about the threat landscape. So when thinking about threat actors, we want to wonder who is out there to get me. And this can vary from state actors to cyber criminals, to people with competitive motivations, to disgruntled insiders, and even vandals, though probably not the kind of vandals that you see on the bottom right of the picture. Now, the motives that these actors that are out there might have vary, but three big motivations in the ICS SCADA space are geopolitics, like we've seen with attacks like Stuxnet or the attacks in the Ukraine, extortion, where people either try to automatically extort asset owners through means of ransomware, or have targeted extortion campaigns, or for competitive reasons. Now, the means in which they can achieve these varied goals can be subdivided into major categories. One of them is espionage, and the other one is sabotage. And we'll talk about different aspects of these two means in detail in this talk. So espionage can go after a variety of different targets. This can vary from corporate intelligence to industrial designs, like process flow diagrams and stuff like that, to chemical formulas, to operational information, especially when people want to get a competitive edge, to reconnaissance for subsequent sabotage operations. Now, sabotage can come in many forms, but things that spring immediately to mind is damage to equipment, industrial equipment, equipment that is being manufactured, damage to your production process, damage to the environment. We all remember the the Deepwater Horizon oil spill, something like that. You don't want to happen because of cyber-enabled means. Damage to performance is a sabotage means where the operational efficiency of a plant is degraded in order to affect its performance. Denial of service, like blackouts on the electrical grid, or even injury and loss of life. Now, recent research by Kaspersky has shown that targeted attacks by so-called advanced persistent threats are a major area of concern for various asset owners. Now, these are very different from opportunistic attacks. Whereas opportunistic attackers usually go for low-hanging fruit, targeted attackers are well-resourced, experienced, and know what to go after, and they have a wide array of resources at their disposal to carry out these attacks. Now, as we've seen over the past years, the number of cyber-physical attacks, though still fairly limited, has been increasing and has been getting more bold. These effectively started in the public eye with the Stuxnet attack in 2010, which was a planned operation to hinder Iran's nuclear program. And after that, we started seeing reconnaissance and weaponization capabilities being deployed in the wild, with the first publicly known cyber-physical attacks after Stuxnet being the dual attacks on the Ukraine power grid in 2015 and 2016, and the recent attack on a Saudi petrochemical facility in 2017, targeting safety instrumented systems. Now, a common thing you hear from certain asset owners is that no serious attacker would be interested in attacking them because they are not that interesting. But as we'll see, that is kind of a fallacy. Because you might be interesting for different reasons. You might not be targeted as part of an attack that actually seeks to damage you or your organization, but you might be targeted as a springboard or part of the bigger picture. Your relations might be targeted, or you might be targeted as part of an attack that seeks to cause a systems of systems cascading effect. Or, equally important, you might be targeted as a training exercise. People familiar with cyber physical attacks know that these are difficult to develop, to carry out, to test. So attackers would like to learn to walk before they can actually start running. And this requires access to live equipment and processes to test the kind of capabilities that they are developing and to study the human behavior and the reactions, both in terms of the defensive response as well as the geopolitical reactions to a certain event before they actually target the actual target that they have in mind. So you might be targeted not because of who you are, but simply because you are easy to target as a training exercise. And that is something you need to keep in mind. All right, so you've started investing in security. Great. Now, how do you know that your investment is actually effective? How do you know that you're not just burning money? Well, one metric for that is compliance. We've spent this many euros and now we're compliant and we're avoiding fines to the degree of a couple of $1 million. That's great and that's important because compliance is a driving force, but it's not the same as real world robustness. Compliance isn't the end of the road. The fines here pale in comparison to real world incident damage. And how will your defenses hold up against a determined attacker? And how will you respond to an actual incident? Being compliant doesn't allow you to know these things, and red teaming does. So you want answers to the real questions, such as, are the right things and people in the right places? Also, what even are the right places? So one thing that I often like to refer to in the context of red teaming is the so-called Rumsfeld matrix of epistemic uncertainty, which is kind of blown up for what it actually is. But what it basically says is that Donald Rumsfeld came up with this metaphor for the complexities of the Iraq war, where he said that we have things we know, we have the things we know we don't know, and then we have the things we don't know that we don't know. And that particular blind spot, your unknown, your unknowns, are the things that you want to uncover using red teaming. Especially because risk is very opaque. Risk is often seen as impact times likelihood, but especially in the ICS SCADA space where you have so little data about actual incidents, it becomes very hard to actually get an idea of what kind of attack likelihood is there. On top of that, likelihood can be inversely related to or at least the conceivability of an attack can be inversely related to the likelihood. A concept that is relevant here is the so-called black swan, which is an incident that has a very low probability but an extremely high impact. One illustration of that would be 9/11. If 9/11 had been conceivable prior to 9/11, it would likely not have happened. It's the inconceivability of the incident that helps create its own fertile conditions for it taking place. So when thinking about cyber physical attacks, we can ask, was Stuxnet a black swan for Iran? Was it basically engineered because it was inconceivable up until that point? And I think to a certain degree that is an apt metaphor here. Then we have question 2 that we seek to address with red teaming. Will those things and people that I have put in place as security measures operate effectively during an actual incident? Because this is not something that you want to find out when an actual incident is happening. So in order to test your security investment, you need to know, is it being effective in the real world? And you usually do that by measuring it against the number of actual incidents that are happening and how many of those are you mitigating and at what stage of the attack life cycle. But you have to ask yourself as an asset owner, how many real incidents are you seeing? Maybe you're not seeing anything. And that can mean 2 things. Maybe nothing is happening yet, in which case you're probably just cruising by on luck, which is bad because defenders get complacent and rusty if they're not exercised regularly. And ICS worst cases are often low frequency, high impact, like I mentioned, these black swan effects. Or maybe you're just not seeing anything at all. Maybe you think we're not seeing any incidents, but that's because you don't have any kind of visibility into your environment in order to detect it, in which case you probably already have a problem. Now, The thing that you need to ask is, how will your organization actually respond to an incident? And here you need to think about paper versus reality. You might have a very coherent incident response plan, but do people actually know what to do when something happens? Who is responsible for what, and who is going to call whom? Because you don't want to find this out when things are actually going down, because the enemy will be banking on your panic and confusion. And you will need to test these things in order to know that they're actually properly in place. And this is where red teaming can help. Enter red teaming. Now, the definition of a red team is an independent group that challenges an organization's effectiveness by assuming an adversarial point of view. And this comes from the military, where an analytic red team would develop the tactics, techniques, and procedures for an opposing force in war games and exercises. And so-called red cells would test the security of military bases and critical infrastructure in order to find weaknesses before the enemy would. Now, red teaming typically begins where compliance ends. So it seeks to be a simulation of realistic, skilled, persistent threat actors in a managed fashion. And that's a key word here. It seeks to reveal those unknown unknowns, those blind spots that you don't have any visibility in. It means to test your defenses by practicing offense. In the words of Mudge, it's a sword that hones the shield for that entire security life cycle that you have, your identification, protection, detection, response, and recovery, to have it exercised by actual offensive practices. Now, people often think red teaming is a synonym for penetration testing, but that's not the case. There are various nuances and differences that I've listed here on this particular slide. So a penetration test typically is very limited in scope, whereas red teaming tries to attack the entire organization, the people, process, and the technology. A penetration test is typically very restricted in methodology, while red teaming is full spectrum. So we exercise all the kinds of offensive capabilities that we think might be realistic here. A penetration test might be noisy because it's announced, but red teaming must be stealthy because you want to exercise and test the detection capabilities of your blue team. Penetration testing is very focused on bugs, on vulnerabilities that you might find, while red teaming is focused on whatever works, even if it is technically relatively simple, even if it is something that, or especially if it is something that you haven't thought about. Penetration testing is very oriented towards a breach, so you get up until the point that you get in, and that's it. Whereas red teaming is very oriented towards post-exploitation and lateral movement. So what happens after you have this initial breach? Penetration test is very oriented towards having access that is whitelisted. So you already get the credentials to be where you are in the network. And red teaming is oriented against a full security stack. So all the measures are in place, and you'll have to deploy your offensive capabilities against that full security stack. And the output of a penetration test is typically a list of prioritized findings with maximized coverage, whereas the output of red teaming is measuring the organizational impact and resilience. So these are very different things for very different kind of levels of organizational maturity. Now, red teaming operations, as I mentioned, are full spectrum, which is kind of an overblown term, but it's a good description for the kind of thing that you can expect. So they can range from physical access, like physical break-ins, to social engineering, to rogue devices, to remote wireless or wired network compromises, and everything in between. Now, the red teaming process itself, I will walk through it in general, and then I will discuss the specific nuances with respect to ICS SCADA environments. So in red teaming, you typically have a combination of these teams, but at least you have the white team, which consists of management, and in the case of ICS SCADA, maybe safety personnel, which guides the exercise. Then you have the red team itself, which is the offense side, and you have the blue team, which does the defense. And perhaps you have a dedicated purple team, or you maybe have purple team meetings, which coordinates and integrates the cooperation between the different teams. Now, red teaming has many different approaches, and there's not a single right one. So what I'm going to be discussing here is not the be-all, end-all, but it is one approach to doing red teaming, and it is the approach that we are very familiar with. So the approach that we really like is the TIBER approach, the threat intel-based ethical red teaming approach, which originated with the Dutch Central Bank and was adopted by the European Central Bank. It's originally for financial sector, but it can be adopted for ICS SCADA environments, as I saw. So the TIBER process kind of works as follows. You start with a generic delineation of the threat landscape, and then you move on to a preparation phase, which starts with engagement and scoping, where you set the flags and the objectives. So what is it that the attacker will be going after? Then you have the procurement of the threat intel and the red teaming services, and then you move on to the actual testing phase, which starts with threat intelligence and then has the red teaming. And somewhere in between, you have your scenario development. And that scenario development is essentially what kind of an attacker scenario do we want to simulate. And you base that on your threat intelligence, but also on the insights of the red team itself. And then you wrap everything up with a closure phase, which has some remediation planning and result sharing to make sure that the whole process is completed cleanly. Now, the key aspects of a successful Tiber execution basically start with proper planning and preparation. Then you ensure that you have careful realism in place to make sure that whatever you're doing is realistic and not just, fun for the red team. Then you make sure that you have clear attribution. So if you're going to be in there and you are deploying, you're deploying maybe malware, you're having malicious connections going into various networks, you want to make sure that it is clear to at least the white team, but not necessarily the blue team, that it is the red team doing this and not another attacker who happens to be in the network at the same time. Then you also ensure that you have operational security in everything. The reason for that is because you are dealing with sensitive environments and sensitive data. And you don't want any of this to expose the customer in any way that is negative. And then you ensure clean closure. You clean everything up, you close everything, and you make sure everybody is informed about the whole exercise. Now, Tiber typically follows the following kill chain, which I modified in the last phase because it's a little bit different for ICS SCADA environments. You start with reconnaissance, and then you move on to delivery, where you actually enter the target environment. You make sure you establish a foothold on the required systems. Then you ensure persistence to be able to persist on those systems. You move laterally in the direction where you want to be, and then you elevate and escalate your privileges to the right level, and you execute whatever kind of scenario you came up with and developed. Now, this is red teaming in general, but in ICS SCADA there are some nuances, and we'll walk through these one by one right now. The first one is that the objectives of a red team in these environments will be very different. So first of all, you need to consider that you're red teaming not necessarily assets, you're red teaming a certain mission. So a certain target has an operational mission, which is various tasks to accomplish a certain goal. So this might be refining oil, this might be enriching uranium, this might be a more specific sub-goal, such as monitoring a turbine condition. It doesn't matter. But the first thing you focus on is the mission that you're red teaming. Because the goal is to protect this mission and not the assets. All the PLCs and the RTUs and the engineering workstations and the networking infrastructure, that's nice, that's interesting, that's the technical meat, but that's not the thing that you're actually protecting as a asset owner. The thing that you're protecting is the mission, which needs to continue in an optimal fashion. So as an attacker, you will need to think about how to impact that rather than thinking about individual vulnerabilities or whatever. So the red team objective should be developed in light of the most prominent and realistic threats to an organization's mission. This might be, for example, achieving the capability to de-energize substations. This might be achieving the capability to reduce the batch quality of a pharmaceutical batch. Doesn't really matter. This is very not only organization specific, but process and site specific. But you will need to develop your red teaming objectives in light of this mission. And this requires insight into the actual threat landscape. So what are the attackers that are actually out there, the guys that I'm actually worried about, what are they doing? How are they doing it? And what could the potential impact be there? And it requires insight into the organization that you are red teaming. The organization, its business processes, its operational processes, its operational technology underpinning those processes, and how all of that interacts and responds to each other. So in order to integrate this, the Tiber testing phase can be modified by basically integrating not only the threat intelligence into the scenario development, but input from the white team. So in this case, input from the white team could be people like site managers. They could be people from process engineering. They could be people from safety teams. They are the various aspects of organizations' operations that have various insights into the things that you want to red team that aid in developing a successful red teaming scenario, which is a little bit different from traditional IT red teaming, where most of the scenario development is far more generic. Now, the next step is knowing the terrain. So you always need to understand the thing that you're red teaming, because if you don't, the results will be poor. You need to spend time learning. A great way to know the terrain is to use either a granular or a very refined version of cyber mission impact assessments. In a cyber mission impact assessment, you essentially start by defining an operational mission. And then you identify the supporting business processes. So what are the business processes that help me execute this mission? And then you decompose those business processes into tasks and activities, and the assets that support these activities that in turn support the tasks. And then you identify what could go wrong, for example, by relying on whatever comes out of process hazard analysis or something similar. And then you feed these insights into your red teaming scenario. So essentially, you're reverse engineering your assessment in order to come up with a cyber-enabled, quote unquote, malicious way in order to cause exactly the things that you don't want to happen to your mission. And doing this in a structured fashion gains some really, really valuable insights. In order to do this, however, you need to understand the process that you are targeting. You need to understand the process physics and the hazards that are involved there. You need to understand the control and safety infrastructure, both in terms of the control and safety engineering, as well as the assets that underpin it, the protocols, stuff like that, and the cyber physical elements. So which parts of this process are actually digital, which ones are fully analog, what are the pathways into causing a certain malicious scenario. Then you need to understand the technology stack, which is very different in ICS SCADA from traditional IT. So you need to understand the SCADA servers, you need to understand the RTUs, the DCS workstations, the building automation controllers, historians, protocol converters. You need to have knowledge about the different field buses, these particularities of industrial Ethernet and industrial wireless. You need to understand proprietary OT protocols, especially when it comes to distributed control systems, because you need to understand the entire architecture in order to navigate through it as an attacker. Because you need to know what and where the crown jewels are. If I have developed a attack scenario, then I will need to know what kind of assets I will need to compromise in order to execute my attack, and I will need to know where they are on the network and how I get there. And this requires very specific knowledge. And in order to obtain this knowledge, I will need to carry out a discovery operation. And this discovery operation consists of traditional network reconnaissance. You're scanning and activities like that, ideally passive if you're in an OT environment, as well as your process comprehension. So understanding the ins and the outs of the process, having access to the process flow diagrams, having access to the piping and instrumentation diagrams, having access to the control logic, knowing what the specific alarms are, all the kind of stuff like that. And you need to know how to achieve your impact. So this can vary widely for the different processes, but the thing that you often see is people will find the vulnerability in some kind of a PLC or an RTU or an IED, and they will say, look, I've compromised the device. And then asset owners will say, great, now what? You need to know how this particular vulnerability allows you to achieve a certain impact. And this can be something like, for example, opening circuit breakers at a substation. It can be something like causing mechanical resonance by messing with variable frequency drives, or it can be something like damaging an ultrafiltration membrane in a water treatment facility. All of these scenarios are different, but you will need to understand the particularities of both the process and the particularities of the assets that allow you to cause a certain impact in order to craft a good red teaming scenario. Another thing that you will need to consider is the attack surface size. So in a typical traditional IT environment, the attack surface size is already quite sizable, but relatively limited if you compare it to industrial facilities where the geographic scope might be much bigger, but also the variety of technologies, the variety of degrees of exposure are much wider and much more complicated than you might consider in a traditional corporate IT environment. Because the attack surface is absolutely massive. It contains both the IT network and the assets, as well as the operational technology network and the assets, as well as the wireless connections, the removable media, and all of these components have their own attack surface itself. And you will need to think about this zoomed layers of attack surface as an attacker in order to properly craft your scenario of where you're going and how you're going to carry out your attack. For example, if you zoom in a little on a specific item like an industrial router, you might consider, for example, Wi-Fi as an attack surface that you might target. Weak configuration, default credentials, protocol vulnerabilities in Wi-Fi chips, stuff like that. You might consider a cellular interface. You might consider services like Telnet, SSH, HTTP daemons over Ethernet, all that kind of stuff. You might consider backdoors. It doesn't matter. The attack surface is very varied, and you will need to have an overview of all of that before you can properly move around. One example, for example, when red teaming these environments, would be using malicious removable media and peripherals. This might be USB sticks, this might be CDs and DVDs or external hard drives that contain malicious executables, that contain malicious documents like process flow diagrams or piping and instrumentation diagrams, or they might be malicious engineering projects. If you are at a facility where it is common to exchange engineering projects using USB sticks, then backdooring an engineering project and dropping a USB stick might be a very good attack vector there. Another attack vector could be, for example, a human interface device emulation, where you plug in a USB stick and you emulate a keyboard or a mouse. Implanted chargers or cables or infected mobile devices as part of a bring your own device policy, as part of subcontractors, or as part of HMI tablets might also be an interesting attack vector for attackers to explore. Another example would be exposed remote connectivity. This can come in various forms. It can be something like a remote desktop connection to part of the IT environment, where an attacker then pivots off a historian in the DMZ and gets into the process control network. Or, alternatively, it might be remote cellular connectivity, VNC over some cellular connectivity to a cellular router that is directly in the operational technology network and allows you to directly interface with various aspects of the process. And these are different aspects that you will need to consider as a red teamer. Another example would be wireless and physical perimeters. For example, you might have a very well-defined physical perimeter, but you might also have industrial wireless connectivity that reaches outside of that physical perimeter. And if I go and I sit outside of the physical perimeter, but I can still interact with this wireless industrial networks, that means that I can interact in a way that, it's probably means that the perimeter is more porous than you initially thought. And those attacks can vary from jamming to interacting with the wireless industrial network in order to spoof censoring values and stuff like that. Another example would be, for example, hacking upstream. If you have a architecture where you have a lot of remote unmanned stations, for example, electrical substations or gas compressor substations, stuff like that, it might be possible for an attacker to break in physically in these facilities, compromise an RTU, and then hack upstream to the SCADA backend. And this is an attack vector that you will also need to consider if this is within your threat model. Now, another aspect is ethics and safety. So operating ethically is not just operating legally. For example, bribing an employee for access. There are the obvious legal issues, but there are also the ethical issues. The employee might be fired as a result of your actions, or the organization might be demoralized. So when you are simulating a scenario like this, you will have to do so in a way that is ethical. And that might be, for example, by simulating a bribed employee, by obtaining, for example, the credentials that this employee has from the white team and not implicating an actual employee. And that's important to keep in mind when you're red teaming. Very important to keep in mind too is that process upsets are not a joke. Industrial environments, especially the OT part, are very sensitive, and the safety of site personnel, the environment, and the red team is the number one during the exercise. A classical example here is people doing an Nmap sweep in the OT network, causing PLCs to crash because of ancient buggy protocol stacks, and that is not what you want. Because even if no accident is caused, it might spoil a product that is being manufactured, cause a spurious or legitimate safety trip, all things that you don't want. If you want to take a look, for example, product spoilage and spurious trips are very expensive. They can cost a lot, so don't do this kind of stuff. You need to know the dangers of the facility that you are red teaming. If you're doing, for example, a physical penetration test, then you will need to know about the various dangers in the various areas. Are there areas where there are toxic fumes? Are there areas where there are explosive gases or maybe radiation hazard? You need to know this before you are going in, because otherwise you might be walking around and it turns out you are in a very dangerous area, causing harm to the red team itself. So in summary here, safety is paramount. Don't touch the operational technology domain without any detailed permission, clear boundaries and safeguards, or maybe not at all. Establish alternative avenues of approach if you cannot touch a particular part of the OT domain. Or if you can't touch it at all, maybe establish alternative proofs of compromise. For example, maybe you do a physical penetration test, and instead of actually interacting with the equipment, just take a picture of you near it. Secondly, have a safety briefing together with the white team. Have the right personal protective equipment when you're doing any kind of physical red teaming. Know the safety protocol. If you are there and an alarm goes off, you need to know what to do. You need to explore all the hazard issues that might come up during the operations so that everybody knows that when something does happen, the proper measures can be taken. Final nuance, realism. So a quote I love is the quote by Otto von Bismarck: "Only a fool learns from his own mistakes. The wise man learns from the mistakes of others." And this is especially true in red teaming. So one thing you want to do when you're red teaming is simulating realistic adversarial TTPs. And that means that you don't want to just carry out any kind of attack. It means that you want to carry out the kind of attacks that are actually happening out there in the wild, right? And what helps there is simulating realistic adversarial TTPs by using, for example, the MITRE ATT and CK matrix, which is a matrix that specifies different parts of an attack lifecycle, such as persistence, privilege escalation, defense, and operator evasion, all the way up to disruption and destruction, and delineates the different ways in which they have observed actual attackers achieving these particular steps in the attack lifecycle. And then basically construct your red teaming scenario from these different TTP techniques as they are observed in the wild, in order to ensure that what you're actually doing, the attack that you're simulating, is actually realistic. This kind of realistic scenario development, however, requires specific skill sets. It requires the skill sets, at least partially, of an engineer, because you need to understand the physical process and craft the damage scenarios. It requires the skill set of a systems analyst. You need to understand the system architecture and the interdependencies that might arise there. And it requires the skill set of a hacker to develop the capabilities to deliver OT payloads, to compromise the various kinds of networking devices and workstations along the way. And you will need a team that incorporates at least subsets of these skill sets in order to properly red team environments as complex as ICS SCADA environments. Now, there are a couple of ways of going about this. One approach could be going in blind, which means that you attack a system without any kind of prior non-public knowledge, which means that the red team knows nothing about the environment that they're attacking. They will only rely on open source intelligence, social engineering, and any kind of discovery and process comprehension during the engagement itself. And you'd be surprised how far you can actually get with this kind of knowledge. But the reality is that attackers, especially targeted attackers looking to cause sabotage, have a far better understanding of the environments that they're targeting once they're targeting them. These are multi-year operations where attackers will have compromised third parties like integrators or contractors, or they will have compromised the organization that they're targeting in prior operations. So they typically tend to know about the process. They know about the assets. They know about the networks. They know where to go. So in this case, you cannot simulate going in blind. You want simulated process comprehension. And this can be done by having a detailed briefing in cooperation with the white team. You might, for example, have the process flow diagrams, the piping and instrumentation diagrams, the process hazard analysis worksheets, and have them in place in order to craft a scenario as if someone had already done all of that prior compromise work. What you do need to keep in mind, however, is attacker return on investment. Now, the more strategic and the more high impact an attack gets, the higher the cost and the complexity in terms of coordination, precision, timing, and uncertainty. A simple attack could be causing a spurious trip or a denial of system of a subsystem. A little more complicated could be opening targeted circuit breakers. But when you get to attacks that, for example, seek to cause a blackout of a specific area or a blackout of a specific area for a specific time, you start to have a far higher investment to get that kind of impact. And the question is, do you want to simulate that kind of attack? Now, the most realistic attacks often are attacks that are simple, so they minimize the required engineering and process knowledge. They are scalable, they maximize cross-target applicability and automatability. So an attack that you can carry out against different processes of the same organization, or that you can carry out against different organizations, is far preferable from something that is highly tailored. They are instantaneous, they minimize the execution time, because the longer it takes to carry out your attack, the more time a defender has for detecting you and stopping you. They are reliable. You want to minimize any degree of uncertainty as much as possible, but keep in mind that advanced and tailored attacks tailored specifically to a specific process of a specific organization might not be mass deployed, but might still be used for very high impact scenarios. Keep that black swan in mind. And that brings us to our conclusion. So in conclusion, red teaming has significant value for ICS SCADA. It allows you to assess and improve the actual organizational resilience. It reveals your unknown unknowns by realistic incident simulation. And red teaming for ICS SCADA is different, but it is doable with the right managed approach, with the right preparation, and with the right partner. So finally, I'd like to draw your attention to the Black Hat sessions in 2019 on the 13th of June, which is Secura's conference. Here we will have a hands-on ICS SCADA hacking workshop where we will show and demonstrate a small process underpinned by various assets, and we will show different ways in order to hack this and how to detect the ways in which an attacker can manipulate your process. I'd advise you to get your early bird until the 20th of April because there are limited seats here, and you can get it on the URL below. I'd also like to draw your attention to our ICS Secura training, which is a 2-day course and consists of an introduction to ICS itself, the threat landscape, and the attack surface. And then we'll move on to a discussion of the details of cyber physical attacks, threat modeling, and impact analysis, as well as standards and security controls. And it will involve interactive sessions as well as lab demonstrations. And finally, there's going to be another webinar on the introduction to IoT security. It's relevant for ICS in that connected embedded systems and the industrial IoT are proliferating a lot these days. It will be on the 23rd of May in 2019 at 3 o'clock. And I will discuss the threat landscape, the common vulnerabilities, as well as some hardening strategies. And you can register on the URL below. And that's it. If there are any questions, I will answer them now.
Yeah, thank you very much, Jos, for a very, very nice presentation. We did receive already a couple of questions. So the first one sounds like this. So when red teaming, what is the relevance of physical security? Does it have a high priority?
So when you are red teaming, physical security is relevant, obviously, to the degree that it is relevant for the specific site that you're red teaming, for the specific process. So it might be that if you have a physically very remote location where it is unlikely that a lot of attackers are going to take the effort to travel to, that it is a little bit less relevant. than if it is an easily accessible facility. Let's say an unmanned substation, an electrical substation in a residential area, where it is easier to gain a certain kind of access. But obviously, this always depends on the specifics of the target itself. So it also depends on what the actual threat landscape itself looks like. So if there are a lot of attackers out there that utilize this kind of attack vector, then you might want to simulate it. But if this is not something that is actually happening out there, then maybe you don't want to put too much attention on this.
Right, thank you. And the second one, which we received, how will you safely red team against ICS equipment?
Yeah, this is of course a very important issue to address. In many cases, like first, the one thing is like don't touch anything in production. Like you want to red team during, for example, downtime windows, or you want to red team against redundant systems, or you want to red team maybe against a lab setup. So, for example, if a red teaming engagement is scoped to ensure that you have, for example, the goal is to go from IT all the way to OT and then see if you can get to a particular sensitive crown jewel asset, then maybe you move in the actual red teaming exercise all the way up until the IT OT perimeter, and then perhaps simulate the rest in a lab setting if it is considered to be too unsafe to do so in the actual OT network. So there are various ways in which you can find compensating ways to test this kind of stuff.
Right. Thank you very much. We received a couple of more questions in the meantime. How can a blue team detect an attacker in a SCADA ICS network?
Yeah, that's a good one. Detecting attackers in ICS SCADA networks can be complicated, mainly because of limited visibility. Typically, and especially traditionally, ICS SCADA environments have very limited visibility on part of the OT network. There's little monitoring going on. There's little out-of-the-box kind of visibility, so you're usually not seeing a lot there. And especially the deeper you go down the Purdue model, the less you start to see. So if you want to do attacker detection, you want to do it as early in the attack cycle as possible, what some people call being left of boom, as far left of boom as possible. So you want to detect them during the early stages, but it certainly helps to have a degree of visibility across the different parts of your network, and to have that visibility in places where you are sure that all the relevant traffic will have to pass through. So if you have a degree of security maturity, you will have perimeters around different segments in your operational networks, and then establish choke points where all the ingress and the egress traffic has to pass through, and then do monitoring there for the potentially dangerous operations, for the different kind of indicators and threat behaviors of these attackers.
Thank you very much. Another question that we received, is an IDS effective?
Yeah, so I mean that is a very broad question. I mean that depends on the kind of IDS, and that depends on where you position it. So if you want to detect attackers during the part of the attack lifecycle where it still resembles, a traditional IT threat, then traditional IT-oriented IDSs might help in those networks. But as soon as you start moving towards the operational networks, you will need a kind of visibility and a kind of technology understanding that allows you to get visibility in those networks that traditional IT IDSs simply do not have. If you don't have parsers, if you don't have an understanding for all these OT protocols, then you're not going to see anything below Purdue level 3, essentially. And that is it. If there are no more questions, then if there are any follow-up questions, feel free to send me an email or to contact me over Twitter with any additional follow-up questions.